Welcome everybody to the course Crystal Engineering, Chemistry Beyond the Molecule. Well, we have Corona time, and this is the reason this course will be held as an e-learning course. But before we start this course, who is the person behind the voice? Have a look. Here I am. My name is Klaus Merz. I'm member of Chair of Inorganic Chemistry 1, and you can contact me by the email you will see on the next slide. I hope I will answer as quick as possible if you have any questions or comment. Okay, let's go on with this first introduction of this lecture. Going back to the slides. Bye bye. We see us again. Yeah? And here is, as I said, the information about me, my contact email address, and each Wednesday you can join one video, or very often two videos of this topic, crystal engineering. I will upload these videos on a YouTube platform. This course is assisted by a Moodle course, and in this Moodle course you will find a lot of materials. For example, scientific contributions from different journals. You will find structure files for molecular structures. You will find a crystal structure visualization software. This is really nice. I will show you it here. This is called Mercury. For example, in this case, you see it. If you have a clear look on this picture, I think you can see it is exactly the molecule from the first slide, plus water. If you want this exactly the same structure, then you can delete the water. Voila! You see this is the structure, and you can zoom in, zoom out, whatever you want. You can rotate, you can have a look on hydrogen bonds, for example. You can, for example, have a look, if you want, the crystal packing. Once again, you see crystal packing of a molecule. For example, in this case, you see very nicely the formation of a layer, and you very nicely see that two of its heteroaromatic rings are linked by succinic acid here. Or, for example, you can choose the style, ball and sticks, or the space fills, whatever you want. You see, it's a very nice program and helps you to understand a little bit better the structure files, and helps you to understand a little bit better aggregation phenomena in solid state. Additionally, you will find slides, and you will find some examinations from the past. Well, these are some information about me. And what's about you? Well, I would say the major target group are persons who are interested in organic and analytical chemistry, and especially are interested in this field regarding solid states. And so this is directly the link to the topic of a lecture series. what is crystal engineering. You can have a look in the internet, you can look in literature, you will find a lot of different definitions. Regarding this lecture series, I would say it is the understanding of intermolecular interactions in the context of crystal packing. This is interesting for us, crystal packing. And why are we interested in this field? Because our job is the design of solids with desired physical and chemical properties. Well, this is a challenge. This is our aim. Designing solids with desired physical and chemical properties. Okay, what's going on in the next weeks? Let's have a look. Here are some topics of a lecture series, and these topics are always the main chapter. I would say for each main chapter we have several sub-chapters. We will talk about aggregation phenomena of organic molecules in solid state. We will talk about crystal design strategies. How can we really synthesize crystals? What strategies are known? What can we use? You have seen on the slide before intermolecular interaction. This is the main focus of this lecture series. We are talking about strong intermolecular interaction, weak intermolecular interaction, and how we can use it for our aim, our job, designing solids with desired physical and chemical properties. We will talk about crystal structure prediction. This is really amazing what's going on in the last 10, 20 years in this field. 20, 30, 40 years ago, nobody thought it is possible to predict crystal structures. Today, it's possible. Why not? We will show. We will talk about polymorphism. Very interesting in pharmaceutical industry. Polymorphism, where it is the phenomena that molecules can aggregate in different ways in solid states. We will talk about multi-component crystals. Multi-component crystals means crystals with two and more neutral molecules in the crystal. Yes. And we will talk about crystallization. I will show you how important the concentration of the solvent is. We will talk about tricks to get a metastable polymorph, tricks to get a thermodynamic stable polymorph, and so on. No topics are, first of all, structure, solution, and refinement of single crystal structures. If you're interested in this topic, send me an email and we will talk about if it's possible in an additional seminar which is organized by me or a colleague of mine. And we will not talk about aggregation phenomena of inorganic compounds. The reason is mostly inorganic compounds are ionic, have ionic species inside. And we will focus on small organic molecules, mostly using neutral species. And we will not talk about aggregation phenomena of morphs. Well, this last topic, if you look in literature, you will find a lot of contributions about this topic. And I would say if we start to talk about morphs, aggregation phenomena. Well, I would say we need an own lecture series about several weeks. It makes no sense to give a brief information summary about this topic in 1 hour, 2 hours. So I decided to avoid this topic. You will find background information, secondary information, interesting information about this topic and scientific contributions in 2 crystal engineering journals. Yes, you hear it right. There are 2 journals where only crystal engineering topics are published, results, investigations in this topic. First is Crystal Growing Design, and the second is Crystal Engineering Communication. And there's a very nice written textbook, Crystal Engineering, a textbook. You see it here. The authors are Desiraju, Vital and Ramanan, and especially the first author, Gautam Desiraju. I would say he's the Pope in crystal engineering, and you see it here. He was president, for example, 2011 to 2013 of the International Union of Crystallography. This textbook, as I said, is very nicely written, especially for students, and it's not so expensive. I would say 30, 40 euro only. Now, here, special, typical contribution in this crystal engineering journal, Crystal Growing Design. The title, Most Frequent Organic Interactions Compressed in Toluene. So what have they done? They investigated the crystal packing of toluene depending of different pressure. You see it here, and they found 4 different crystal packing depending of the pressure. Well, now one of the most important questions. Are you still interested in this course? You must decide. If you say yes, okay, well, have a look here. As you have seen, I will upload several videos regarding topics in crystal engineering. And at the end of the lecture series, there will be an examination, I think in August. I will inform you about the exact date, with this special situation, COVID-19. And now have a look here, the last sentence. Not only I present videos, also you. And that means in the last lesson, in the middle of July, you will present short videos of selected crystal engineering topics. Have a look. Here is the timetable, the dates of the videos. You see here the last, marked with a red dot here, is 14th July. This is the date where you present short videos. What does it mean? You will find this information in the Moodle course. In the middle of July, please present short videos. It means less than 10 minutes, around about 10 slides, not more, plus your voice. If you want, like this moment with a photo, but it's not necessary. No? Slides plus voice soundtrack. And these topics you will find in this doodle. If you click on this doodle link, there will topics around about 10, 12 different publications. All this publication you will find Crystal Growing Design, one of his journals I've shown you regarding crystal engineering topics. Please, you present as a team your talk. Yes, this is very important. Please work as team. So I don't want to get 2 videos from 2 persons, always only 5 minutes, together 10 minutes. You sent me 1 video about 10 minutes, was constructed, designed by you as a team. And the team is 2 persons, 2 students. Have a look here. 2 very important deadlines are here written. First deadline is round about middle May. Until this date you must choose one topic. Yes. And the second is at the end of June, please send me your completed talk. And then I will have a look and maybe I will say, well, okay, comment. Nice talk, but too much information, or please focus on this topic or this point, this issue, or something like this. No? Okay, and then I will upload your talks, and your talks are designed as the final version as an MP4 video file. MP4. No? No talk on end of June, no presentation on middle July. The talk will be marked a part of a whole crystal engineering lectures and must be better than before. And you see a part is part of the final grade of a lecture series. To design your video, you can please use a screen recorder, and they're very easily to get internet. Several freeware screen recorder available. You see it here. And if you really want to use Linux, like this video, you see it here. You can use, for example, Kazam. No? The topic you will find in the doodle list here, 1, 2, 3, and so on, 12 different topics, and you see it all, a team, 2 students. The information, the contribution here for the first or the second, you will find the Moodle course. No? For example, first here, quantitative investigation of weak atomic interactions of fluorine and CF3 substituted in situ co-crystallized benzaldehyde, for examples. Typical contribution crystal engineering, published last year. I see it here. If you need more information about this publication, this contribution, for example, crystal structure, and these are very often placed and stored in the supporting information, when click on the homepage of Crystal Growing Design. Don't forget, if you're working from home, you need VPN tunnel. Look for your contribution, and when you see it here, when you will find here a button for supporting information, you can click and download the supporting information. This is a typical list of contributions. It's not from this year, I'm not sure, last year or 2 years ago. You see it if you look. It's very typical topics in crystal engineering, and very different topics. Sometimes different techniques, sometimes new approaches to design special crystals, sometimes focusing of a special intermolecular interaction, something like this. No? You see sometimes calculations, sometimes predictions. You see this broad field in crystal engineering, and you see it here with diverse and very interesting, I would say interesting from my point of view, different talks in computer motion. Well, okay, with this first information about this course, and I will end with information that during this course we have several online exercises, and in these online exercises we will always only discuss the result of your exercises. So I will not present the exercises, discuss the exercises, and I'm more like a moderator, and look what have you done and how have you handled the exercises. We will discuss together these exercises. Okay, now I will see, hopefully you, next time. Bye bye. Where's my hand here? Bye.